Good evening. Welcome to this session. In this session, in the extension of our basics on ellipse and hyperbola, we studied in our previous session that the two basic forms x square by a square plus y square by b squared is equal to 1, and of course x square by b squared plus y square by a squared equal to 1 are the two different forms of ellipse. The difference is the major axis along the x, and in second format the major axis is along the y axis. The other more forms we can go for the extended basic types. What do we mean by the extended basic types? In the standard basic, the center is always origin. They are centered around the origin, 0, 0. In the case of extended basic, let us assume the center to be h comma k. So that being the case, let me just sketch the center h comma k. Center is h comma k, focus 1 and 2, vertices a and a dash. So we are very familiar about the length a dash being 2a, b dash the length being 2b. We are familiar. If the center is h comma k, then the equation gets modified. It is x minus h whole square by a square plus y minus k whole squared by b squared equal to 1. So this is how the equation gets modified. What else gets modified? Any kind of distance doesn't get modified. Length of major axis to a, length of minor axis to b, and the relation c equal a square, c square is a square minus b squared, eccentricity c by a, all that doesn't get modified. The length of LLR, length of latus rectum twice b square by a. So they are terms which remain unchanged, constants. But the focus 1 or focus 2 will now be the already existing x distance h. From that you have to move c units. To get f2 from x coordinate h, move to the left or subtract c units. So this is how the foci get modified. How does the vertices get modified? It's easy for you. So h plus a comma k, a dash h minus a comma k. What about the ends of minor axis? So it is h k plus b. And what about the b dash? H comma k minus of b. And what about the directrices? So the directrices will also, their locations are changed, so equations will be, but still understand that they are parallel to y axis. And a dash, the major axis still parallel to x axis. Okay, so directrices will be x minus h equal to plus or minus a by e. In other words, x equal to h plus or minus a by e. So those two directrices equations will be obtained by adding or subtracting a by e to the x coordinate of the center h. Fine, these are the modifications that you will have to take up. The same thing we can apply to the other case also in extended basic for the format 2. So in the case of form 2, we get x minus h whole squared by b squared, y minus k whole squared by a squared equal to 1. Center, no doubt, h comma k. And please understand, the focus will be now, the foci will be along the major axis, but major axis is parallel to y in this case. So h will remain as it is, y coordinate k, and you have to add c, and f2 shall be h k minus of c. The vertices a dash, a, h comma k plus a, and h comma k minus of a. Minor axis, the ends b will be h plus b comma k, b dash h minus b comma k, center h comma k. So this is how you will have to go for the modifications. And as I told you, the length of latus rectum twice b square by a doesn't get changed. Eccentricity relation is never changed. So this is the concept. And for directrices, you will write y equal to k plus or minus a by e to get directrices. Okay. So this is how we get the modification for the extended basic types. Well, let us look into a basic question I will take up. Okay, so 9x square plus 4y squared minus of 6x plus 4y plus 1 equal to 0. This represents equation of ellipse merely by looking at the sign between x square term and y square term. So the sign present between x square term and y square term, if it is positive, you understand it is a ellipse. Of course, fulfilling all the other criteria. Well, I have given you this equation, and probably I can give you some tasks. Find focus, find foci, find the vertices, find eccentricity, find length of latus rectum, etc. How we will approach? So that is the idea here. This can be you can see it as a very basic CBSE variety, or it can even be a basic JEE mains question. What I am doing is collecting x terms. I am just able to gather the 9 common, 9x square. Here 6x is there, so there is a minus sign also, x term. So I find 6, after taking 9 out, I get 2 by 3. 2 by 3. And taking 4 common, I get y square and 4y, so 1 inside. And let me give some space. There is a constant term minus 1. Let me take minus 1 to the RHS. So that is what, this is how we get modified. This is how we are modifying. Slowly we are turning it into this extended basic type, x minus h the whole squared by a squared plus y minus k whole square by b square. Now let us add suitable constant. So let us add suitable constant to complete the square. So half of x coefficient is minus 1 by 3. So I add 1 by 9. So I add, to balance the equation, 9 times 1 by 9 on the RHS. And here there is only 1y existing. It was 4y squared, 4y. So half of it is 1 by 2. Now add 1 by 4, add another 1. Because 4 times 1 by 4 is 1. So I add 1 on the right. So what I got is ultimately 9 times of x minus 1 by 3 the whole square, 4 times of y plus 1 by 2 the whole square. RHS is 1. RHS is already 1. So what do we understand? So where is the a square and b square now? Very simple, it is x minus 1 by 3 whole square over 1 by 9. Y plus 1 by 2 whole square over 1 by 4 is equal to 1. Now students have a tough task. The term x minus h whole square by a square, usually students assume that way, y minus k the whole square by b square, okay, but the terms are actually not placed correctly, positioned correctly. Why? Because comparing 1 by 4 and 1 by 9, so anybody can see 1 by 4 is greater, 1 by 4 greater than 1 by 9. So if I take 1 by 9 as a square, definitely I will be wrong. 1 by 4 should be greater, 1 by 4 is a square, because in case of ellipse, students should understand always a greater than b. The length of major axis greater than length of minor axis. Therefore, a greater than b, a square greater than b square. So the correct format will be y plus 1 by 2 the whole squared over 1 by 4, which is a square, and b square is 1 by 9. So plus x minus 1 by 3 whole square over 1 by 9 is equal to 1. Now we are in a position to answer the coordinates of center. The very first thing what we come across is x minus h, y minus k. Therefore, I can say 1 by 3 comma negative 1 by 2 is coordinates of center. Compare with x minus h, x minus 1 by 3, y minus k compare with y plus 1 by 2. So h is 1 by 3, k is negative 1 by 2 is the center. And because y squared by a square comes, okay, the a square is placed below y plus 1 by 2 whole square. So this is the shape of the ellipse. So foci and vertices are along the major axis, of course, and major axis is parallel to y-axis. So you can follow the other routine, yes, what we highlighted in the second part. So now let us see whether you can highlight the foci. What about the value of c in this case? So we should know c squared is a squared minus of b square, which means c squared is 1 by 4 minus of 1 by 9. That means 5 over 36. So c value in this case is root of 5 by 6. Okay. So because once you got the c value, we will be in a position to fix f1 as h comma k plus c. It is the y coordinate which you are going to change. X coordinate 1 by 3, no change, minus 1 by 2 plus c value root 5 by 6, that is one of the foci. The other one will be at 1 by 3 minus 1 by 2 minus root 5 by 6. So which happens to be the pair of foci in this case. Okay, so this is what the coordinates, the desired coordinates foci. What about the coordinates of vertices? In case of vertices, so a, h no change, k plus a and minus for the a dash. So h, that is 1 by 3, there is no change, and there is negative minus 1 by 2, add a. What is a here? We got 1 by 4 as a square, so a is 1 by 2. So add 1 by 2, which means I get 1 by 3 comma 0, one of the vertices. Other vertex will be 1 by 3 comma minus 1 by 2 minus 1 by 2, which is at 1 by 3 comma negative 1. So we are able to successfully find vertices. Now ratio, the eccentricity ratio is c by a. C value already you got it as root 5 over 6 divided by a value 1 by 2. So that gives the answer root 5 by 3 for eccentricity. Done. And we come to the length of lattice rectum. The expression for that twice b square by a. B squared is already here for you, it is 1 by 9, and a value 1 by 2, so the answer will be 4 by 9. That is the length of lattice rectum. So that is also completed. So we are able to complete all the questions or subdivisions, or in the case of MCQ, these answers appear as options, whatever. So what we have done is, the given equation you have to properly go for completion of square, collecting the x terms, collecting y terms, pushing the constant to the right side, and properly make a smart decision which is a square and which value is b square, and decide accordingly whether major axis lies along the original format along x axis or the revised form along the y axis, and then you can decide the locations, the coordinates of the other parameters. Fine. What about any, suppose they ask you equations of directrices. So I am just extending the question a bit more. Equation, when we say directrices, Definitely what we mean is equation of directrices. Equation of directrices in this case, because it is oriented parallel to y-axis, we can say y equal to h, no change. So k plus or minus a by e. So the y minus k part is equal to plus or minus a by e. In other words, y is k plus or minus a by e. We already have understood what is a. We already found e value root of 5 over 3. So what is a by e? It is 1 by 2 times 3 by root 5. 3 over 2 root 5 is a by e value. So is that a 1 by 2 divided by e. Now we adopt the equation y is equal to k. Well, k is minus of 1 by 2, okay, and plus or minus of 3 divided by 2 root 5. This forms equation of directrices. So we are ready for the equation of directrices also. Sometimes they can ask for some other parameters like distance between the two foci. So means f1, f2. F1, f2 is always very simple. It is 2 times of c. Distance between foci is always 2 times of c. So once you got the c value as root 5 by 6, you can apply 2 times root 5 by 6. In other words, root 5 by 3 units will be the distance between foci. Okay, so this way you can give a complete geometric description by analyzing various parameters pertaining to the ellipse in whatever format it is given. Thank you, students. We will stop here, and I will meet you in a similar example taken for hyperbola. Thank you.